So in the last video, we were pondering the question about where the moon came from, or what the moon's origin might have been. And we have these four theories: fission, something breaking off the Earth; capture, gravity capturing something flying by; condensation, rocks sticking together; and ejection. And maybe there was a massive collision that blew some big part of rock off the Earth, forming the moon. So we'll go through these theories here, and I'll tell you how they work a bit. But of course, any theory that we decide might be the right one has to have some evidence behind it. Like, it has to be backed up by evidence. Things we see today have to be consistent with the picture. So evidence is sort of what we see today out there. Okay, so let me just give you some evidence. The first bit of evidence here is that the moon has the same density as the Earth. And I mean, these are density, what you would think of here, sort of the mass of the rocks divided by the volume of the rock, which you might have learned about in a physical science class you might have taken. And that number at the moment here is about 2.3 grams per cubic meter. So the moon and the Earth, the rocks, have the same density. In other words, what the density means is in every cubic meter, so suppose you drew a cubic meter of matter, something like this, like a box. That was 1 cubic meter, like 1 meter on a side. So every one of these sides here was 1 meter, 1 meter, and 1 meter. If you drew a box like that, and then you tried to cram in a bunch of rocks into this 1 by 1 by 1 meter cube, you would be able to get 2.3 grams of rocks in there. That's what the density means. So it turns out that the moon and the Earth share this common density. So that's kind of interesting. And so then you go back up here to the category of plausible mechanisms for how the moon might have formed. And let's just say if we call this the density D evidence right here, well, fission would definitely support that, because fission is about something breaking off the Earth. So if something broke off the Earth, it would have the same density as the Earth. That's fine. Capture doesn't really support that. It would just be a coincidence then that the thing that got gravitationally captured had the same density as the Earth. Condensation, that doesn't really support it either, because if there's a bunch of rocks floating around the Earth that collided and stuck together, they wouldn't necessarily have the same density. But ejection is also supported by that one too, because obviously something got blown off the Earth, it would have the same density as the Earth. So see, this is what I mean by the evidence here. It looks like so far the density argument only supports 2 of the 4 plausible theories. So we'll see what happens there. Okay, the second bit of evidence is that the moon has no iron on it. Okay. Iron is sort of an interesting element here because it's very heavy. And so usually it's commonly found deep in the core of a planet. How does that happen? Well, when a planet was forming initially, it was very hot and molten. Think of it like a ball of lava. And so what happened then is, as the planet cooled, maybe there was some iron sort of all over the place on the planet like this. But then what happened is, because the planet's in this molten state, the heavier things like the iron would have started to move towards the center of the planet, because they're heavier, and heavier things tend to sink. So this is called differentiation. And what that of course means is, like I just said, heavy things sink, and light things are going to rise. And so we have the Earth, the way the composition of the Earth is anyway, we have likely a bunch of iron at the core, and then the lighter things, like maybe, I'll say the silicates, are at the top, and that's differentiation. So the moon doesn't have any iron on it, and the other place that doesn't have any iron on it that we know of is for this differentiation reason like the Earth's mantle. Okay, the Earth's mantle, of course, is this very upper layer right here, and that doesn't have any iron on it either. And so what this theory sort of tells you here is that there's no iron on the moon, and there's also no iron on the Earth's mantle. Okay, so we'll call this I'll put an I right here for evidence. And we'll go back up to the list of reasons here and see if we can complete this table a bit more. So we'll write an I. So it turns out that fission, okay, a part of the Earth breaking off, that may support, no, I don't think so. I'm saying no, that does not support the iron, because if a piece of the Earth broke off, it probably wouldn't have been the core of the Earth. It would have been something closer to the surface. So there is no I here. So the iron theory doesn't support fission at all. Capture isn't really supported either, because there's, well, no reason to believe that something flying by would have a lot of iron in it, although meteorites out there that fall from the solar system and beyond often do have iron on them, but not a rule there. Condensation doesn't really support this either, because there's no reason to believe that rocks flying around the early Earth would have had a bunch of iron in them. Then, of course, you have ejection here, which is if something hit the Earth, likely parts of the mantle or what would have been ejected out away from it. And if the iron was very deep, there wouldn't be any iron in the ejected body either. So see, the I doesn't really get a lot of support for any of these mechanisms, actually. Okay, but sort of looking at it here, yeah, I was going to say, loosely speaking, that maybe we should draw a really light I and a small one next to this one, and maybe next to this one, because it's possible some of the iron from fission could have been pulled out of the Earth's core, and possibly here too, but it's weak, and so we'll leave it there at the moment. Okay, so next video we'll look at a little more evidence.